Hey everyone, and welcome. Today we're going to talk about something really core to how AI works, making choices. How does an AI, when it's staring at a mountain of different options, actually decide what to do first? Let's dive right in. Okay, so just picture this. You've got an AI agent, and it's trying to juggle like 100 different tasks at once. And these aren't simple tasks. They have conflicting goals, they have limited resources. It's a mess. It has to do something. But where does it even begin? And this isn't some sci-fi thought experiment. This is the reality for AI systems every single day. Because if there's no plan, it's just chaos, right? The agent freezes up, tasks start piling up, resources get burned for nothing, and in the end, it just fails. It's basically the AI equivalent of just spinning your wheels and going nowhere. We can call this whole problem AI's choice overload. Think about it. In any complex situation, an agent is just getting bombarded with potential actions. The real trick, the real challenge, is going from that overwhelming sea of choices to actually doing something purposeful and logical. So, how do you solve that? Well, there's a really elegant and powerful idea for this, and it's called the prioritization pattern. This is the secret sauce, the structured method that takes all that potential chaos and turns it into focused, intelligent behavior. Okay, but what is it really? Well, think of the prioritization pattern as a rule book. It's a framework that lets an agent look at everything on its to-do list and systematically rank it all. It uses specific criteria, things like how urgent is this or how important is it, to figure out what absolutely positively has to be done right now. And the way this works is actually pretty cool. A user gives it a prompt, right? The agent gets it, but it doesn't just jump into action. No, first it consults its built-in list of priorities. It weighs the request against its own internal rules, and only then does it come back with a smart, prioritized response. So let's get into the nitty-gritty. How does an agent actually make these calls? It's definitely not magic. It's a super logical, structured process. Let's break it down. It really comes down to these 4 key parts. First, you've got to define the criteria, basically the rules of what matters. Second, the agent evaluates every single task against those rules. Third, there's some scheduling logic that figures out the best next move. And finally, and this one is so important, there's dynamic reprioritization. That's the ability for the agent to change its plan on the fly when new information comes in. And what are those criteria we're talking about? Well, honestly, they're pretty much what a great project manager or even an ER doctor would use. How urgent is this? How important is it to the overall goal? Do I need to do something else first? Do we even have the resources to pull this off? It's basically a super fast cost-benefit analysis happening in a split second. And here's a key thing to get. This isn't a one-and-done decision. This is happening at every single level. So an AI might have a huge high-level goal, like, say, winning a chess game. That's the big picture. But it also has to prioritize its very next tactical move. Both of those decisions, the big and the small, are using this exact same pattern. All right, so that's the theory, but where is this stuff actually being used? Let's look at some real-world examples, and you'll see this pattern is absolutely everywhere. Let's start with a self-driving car. It's always juggling things like what's the best route or how do I maintain speed. But the second it detects a possible collision, bam, the task of braking shoots to the top of the list and overrides everything else. Safety becomes the one and only priority. Or how about cybersecurity? An AI watching a network can't just deal with alerts as they come in. That would be a disaster. It has to rank them by how severe the threat is. That way, a massive potential data breach gets handled instantly, while some minor login issue can sit in the queue for a bit, which is, exactly what you'd want it to do. Here's a classic example: automated customer support. Imagine a bot just getting flooded with requests. If it doesn't prioritize, a supercritical ticket like "our entire system is down" could get buried behind 1,000 password resets. This pattern is what makes sure that system down ticket gets flagged and escalated immediately, saving the day. And then you've got the crazy world of financial trading. These bots are swimming in a constant stream of data. The prioritization pattern lets them instantly decide to make a trade based on a sudden market swing, pushing aside less urgent tasks. We're talking about a world where milliseconds matter, and that single decision can be the difference between making a fortune and losing one. Okay, so we've seen it out in the wild, but how does this get built? Let's pull back the curtain a little and look at how this is actually coded. This will show you it's not just some abstract idea. It's something you can actually build. If you look at the prompt for an AI project manager, you'll find this one single, really powerful line. It's an instruction that tells the agent what to do when it's missing information. And this isn't just a hint. This little line is the absolute key to making it autonomous. So why is this one instruction such a big deal? Because it gives the agent permission to fill in the blanks itself without having to stop and ask a human for help. When it makes a reasonable default assignment, it can just keep on working. And that ability to deal with messy, incomplete information, that's what makes it a real intelligent agent, not just a simple script that breaks the second something is missing. So when you put all this together, you start to see the bigger picture. This pattern isn't just about ticking boxes on a to-do list. It's really a blueprint for building agents that are truly autonomous, agents that can think, reason, and actually get things done out in the real world. And really, mastering this idea is fundamental. It's the bedrock for creating AI that's more than just a simple tool. It's about building a reliable partner that can handle complex situations all by itself. At the end of the day, this prioritization pattern is what lets an AI graduate. It moves from just mindlessly doing tasks to actually making proactive, strategic decisions. It's a huge leap forward, bringing us closer to those intelligent, adaptive systems that we've been imagining for years. And that leaves us with one last, and maybe most important question to chew on. As these agents get more and more autonomous, and they start making bigger and bigger decisions for us, how do we make sure their priorities always, and I mean always, line up with our own?